All right, we're going to get into building our first circuit. Now, this is sort of the most basic circuit, and we're going to spend a little extra time here making some variations on the setup of the circuit and the software code itself because I want this to be understood from the outset that we are completely in control of this little computer brain, and it is only doing what we tell it to do. There will be days, hours, late nights where these things are acting very strangely, but trust me, they're only doing what you tell them to do. At least at this point, the AI will take over soon enough. So let's go back to our Arduino environment. This example is our digital input, and it is a sketch called Blink. It is in your examples under basics, and you'll see it right there, Blink. Let's open that code. There's a bunch of interesting information here at the top. Obviously, it's commented. You can see it's in this light gray. What I really want to start with in terms of understanding how do we know where to get the parts and what parts we need. Often, but not always, the examples we'll have in these built-in tutorials. So I just click on the link inside the Arduino code. It takes me to the Blink project page, and check it out. We need an Arduino board, and we need an LED and a 220 ohm resistor. It says optional, but we're definitely going to play with that stuff today. So an LED, hopefully you've seen one of these before. It is one of the more basic, useful components that we'll play with in any kind of circuit. They're good as indicators. They're good as actually something that just creates light. What I want to point out here is that an LED is polarized. In fact, by definition, it's polarized. It is a light-emitting diode, and a diode is a circuit that only allows, or a component, I should say, that only allows electricity to flow through it in one direction. We can tell the positive leg versus the negative leg, and that's a power connection description of an LED. When we look at it, we should see that one leg is slightly longer than the other one. The long leg here is, and I'll lose focus if I move my hand there. The long leg is going to go to the positive end of the circuit. So there's our LED. Now we need a 220 ohm resistor. I asked everybody to pick up one of these resistor kits from SparkFun. I gotta be honest with you, this is one of my favorite things that SparkFun sells because it's an excellent and very clear way to organize what otherwise is more than a little intimidating, and it's a pile of very specific little ceramic resistors. So without belaboring like the reason we're picking a 220 resistor today, but other than that we were told to, I'll explain. We'll talk about Ohm's law in the near future, and it will explain how we actually calculate what value of resistance we want to put into a circuit and so on. It's a really cool trick, and it's a little bit more than the scope of what we want to do today. Inside, if you open your, it's the first page of your resistor kit from SparkFun, you'll see these values. There's little images and little color-coded labels here, and they tell you what value each resistor is in ohms. That little tiny symbol there that sort of looks like some headphones is the ohm symbol. It's saying that to the left, we've got resistors ranging from 0 to 47 ohm. And on the right, we've got 100 to 680. And the second one down is our 220 resistor. That means on this side, on the second page, so to speak, we will find our 220 resistors. They look like that. Come on, awesome autofocus. You can see them there, and you can see that that is indeed the red, red, brown, gold stripe pattern that you see on its label. So let's just pluck one of those out. Set this aside. Here's our 220 ohm resistor. Come on, awesome autofocus. And it is not polarized, meaning we can connect it electrically in any direction. We could connect it this way. We could connect it that way. It's going to be just fine. So I've got my 220 ohm resistor. I've got my LED. And I've got a couple of jumper wires. Now, a note on jumper wires. I am super uptight about color coding my jumper wires. I'm so uptight. I literally spend taxpayer money doing this, separating out bags of different colors. And the reason is, I think it is much easier to keep things sorted if, by whatever sort of rubric you determine, you stick with certain colors to express certain things. For me, I'm pretty much always using a red wire for my positive voltage. I'm pretty much always using a green or maybe black wire for my ground. And I'm pretty much always going to use a yellow wire for signal. So I've got these laying out here. Let's go back to the screen, and here's something even handier. Look at this. They show us exactly how to construct this circuit from our Arduino to our breadboard. So let's give that a try. I am going to first take my LED, and remember these short rows are electrically connected, so I want the two different legs of my LED in two different short rows, and I'll just make a mental note that the long lead of the LED is facing away from me. There's another angle on that if that's helpful. Okay, I'm gonna go back to my reference image. Now it's a little hard to see, but right here, let's zoom in on that. Our 220 ohm resistor is connected to the long leg of the LED in the same row. So I'm going to start with that. And then I'm just going to let its spacing kind of stay the way it is manufactured without bending it around too much. Let's zoom in on that a little bit. Okay, so I've got the long leg of my LED connected to the same short row as one end of the resistor, and then the other legs are sort of outside of that setup. Let's go back down here, back to my reference image. I want to zoom out to see that this black wire is connected to ground. So I'm back here, I have a green wire. I'm gonna go to ground right here. And the other end of that is connected to the short leg of the LED. So that is here. I'm gonna go back to my breadboard, plug this into the short leg. Cool. Back here, and I can see that the other end of the resistor goes directly to pin 13. Back to my board. 13 is right in front of that ground wire. And I'm going to connect the resistor and the same short row of the LED to that. There's another view of that, if that's helpful. And, oh no, 311 is pointing. Yeah, that's not happening. There we go. Okay, no more 311. Here is our circuit connected to the best of our ability and belief, the way that we see it here. Okay, so back to the software actually. Again, We've already selected the proper board, the proper USB port, no problem there. We're going to go to the upload button, and I'm going to leave the Arduino software screen open here so that you can see what's happening. Yeah, okay. So we're good. Done uploading. That decided to work this time. So we look closely at our circuit. We have connected it properly. This is digital output. So this is the blink sketch. You can see that the number 13 pin here on the board is blinking at the exact same time as this new external component that we've added into the circuit. So I want to demonstrate something about why that's happening. Why are 13, the built-in LED, and our LED blinking at the same time? Well, they're electrically the same pin, essentially. How do I know that? Well, it's the built-in LED. How do I know that? Let's take a look at the blink sketch. I'm going to scroll down here. So in our setup, there's a note, a comment that says, let's initialize the digital pin LED built in as an output. Now, we talked about this earlier. Any color-coded word in Arduino is part of the Arduino environment already. So LED built in this case, is referencing pin 13. I want to show you how to change that. First, let's talk about what's happening with the function of it. Digital write in the loop. Digital write, the LED pin high. We talked about that as a description of digital output. Delay for 1,000. Now this is milliseconds, so 1,000 means 1 second. And digital write LED built-in low or off, and delay for 1 second. So when we look at the circuit again, 1 second on, 1 second off, 1 second on, 1 second off. That's what that code means. Let's change something here in the code. Let's try just changing the delay. I'm going to say, let's change this to 200 milliseconds, a fifth of what we had before. Upload the code. This is what we should see. Go fast. Go fast code. Uploading, blinking. Now we go back to the LED, and now we're blinking on and off for 1/5 of a second. Okay? Back to the code. Let's change this back to off for a full second. What will the effect be? Pretty simple. It's just going to kind of flash on for 200 milliseconds and then go off for a second. Okay? So we can already start to model a little bit of behavior in just 2 values inside of our code. Now, what if, for starters, we change this all back to 1 second? Okay, so this would be blink on for a second, off for a second, on for a second, off for a second, on for a second, off for a second, in a loop forever. But what if we wanted to move the blinking LED to a different pin, something other than that pin 13? So our built-in LED is always blinking, but let's isolate the LED that we made by creating a new variable. We're going to do this by making a little space up above the void setup. Now, variables have at least 2 types in a sort of umbrella view. There are global variables, and then there are local variables. A global variable, and this is an integer variable. We'll talk more about this meaning as we go. Again, this is crash course. We want to move fast. Integer variable, let's call it LED pin equals pin 8. And then at the end of the line, this is a syntax issue, we're going to add a semicolon. So what this line means is, well, let's just add a comment. We're going to make an LED pin connected to Arduino pin 8. Okay, perfect. Now, let's go down to the setup. In the setup, we see a function called pin mode, and that's saying we want the LED built in to be an output. Well, we're going to get rid of the built-in LED, and instead of LED built in, we're going to use the name that we created in our variable above, LED pin. It's still set as an output. We want that as a digital out. Same thing down in the loop. We just want to copy LED pin and paste that in where it says LED built in. Now, anytime I'm changing a bunch of code, as often as I like, and I recommend doing it frequently, I can verify it. Now, verify it just means, have I written this code properly? And you're going to see down here, it's still going to compile the sketch. And if you see it say done compiling and you don't see any highlighted error messages up here, you've done well. So let's try uploading this and see what happens to our circuit. So right now, we've still got pin 13. Arduino's talking to the computer, and voila, pin 13 has stopped blinking. Okay, so all we need to do to reconfigure this circuit is take the output pin jumper wire away and move it to pin 8. And lo and behold, now our built-in LED is no longer defined as the blink. We are on pin 8, and it's blinking just as before. And we could change that code just the same. So what are we actually looking at as a digital output? This is a good way to think about it. Take your jumper wire out of pin 8, disconnecting the LED, move that wire over to 5 volt on this side. And look what happens. Our LED is simply on. Because electrically what's happening is our LED is connected to power and ground by way of a resistor, which is just stopping it from being overpowered, frankly. And it is a constant on. It's constant supply of voltage. So that is like on a graph, high, it is on. If we move this jumper back to 8, you can start to understand what, as a digital output, Arduino is doing. All it is doing is saying, turn the power on pin 8 for 1 second, and then turn it off, and then turn it back on. So that is digital output. That is a super common basic function of any type of Arduino project. I'm going to pause here and get set up to do digital input.